Hey, what's up, guys? John here again. So today, let's take a look at another LeetCode problem here. Number 527, word abbreviation. It's a hard problem, but it gets us almost more than a half of the downvotes because even I don't quite like it. But but I still want to talk about this because it's a even it's still like a very interesting problem. Okay, let's take a look. So you're given like an input of a string here, right? A list of string. And you need to generate the minimal possible abbreviations of every word following rules below here. So the rule for the below abbreviation is you take the first character and the last character and then you replace all the letters in between with the number 2 here. See, that's the first. Basically, you begin with the first character and then the number of characters abbreviated, which and then followed by the last character. So in this case, the like, right? So this like becomes the L2E, right? And then it also says if the abbreviation doesn't make the word shorter, then keep it as original. Well, actually, this thing is even confusing because it says even the abbreviation doesn't make the word shorter. Oh, you're right. Sorry, I got confused. So this one it made it shorter because it was 4 length, and then now it's 3. Okay, so but for example, the God here, right? For the God, the abbreviation is going to be G1D, right? Which is the same length as the original word. That's why for the God we just keep it the same thing here. And okay, so the number 2 is the tricky part. So if there is any conflict that is more than one word share the same abbreviations, a longer prefix is used instead of only the first characters until making instead of only the first character until making the map from the word to abbreviation become unique. In other words, a final abbreviation cannot map to more than one original words. So what does this one tells us? Basically, it tells us, for example, this internal, right? Internal. It was like I 1, 2, 3, 4, 5, 6, right? 1, 6L, right? And then there's a like another word interval, right? So this interval, okay, so this interval is also I6L, right? 1, 2, 3, 4, 5, 6. So two words after the abbreviations, it becomes the same abbreviation. That's why we have to that's why we need to change it because we don't want them two words to map to the same abbreviation. So in this case, what's our strategy here? Basically, we'll be starting from the beginning until we find the first different letters here. Right. So in this case, the first the first different letter in our case is the N and V here. Sorry about. So it's this N and V, right? So that's why we have to keep the beginning at the prefix to to tell the distinguish to tell the difference between those two words, right? So basically the prefix instead of I here, right, it becomes in INTRN, and the rest will be our new abbreviation. But since the rest is like less than 3, right? It's less than 3, so it won't make the abbreviated versions even shorter. So that's why we keep the original word, right? That's why we're keeping the internal and interval. And yeah, basically we just keep doing it until everything, all the until every abbreviations is unique. And also we need to keep the original orders for those. I think uh, one of the misunderstanding here is that, let's say we have a hmm, we have a a b b c c, okay, and another like a a b b hmm, c c. I'm not sure if this is the correct answer. Okay, a c hmm, b b c c. Okay. Oh, actually, I got a better example here. So let's see, A, B, C, D, E, F, G, right? And A, B, C, C, E, F, G, right? And then A, B, C, C, K, K, G. Okay, so let's say we have these three letters here, right? So as you can see at the beginning, all of them will be abbreviated to like A 5 5G, right? This is A 5G, and this is also a 5G, right? So the I think this problem is asking us try to increase, basically try to I mean, if we are going this route, right? Let's say if we are abbreviated them into this shortest abbreviation versions first, and then our approach we need to like try to keep increasing the prefix one by one for all the letters, not just for two of them. Because I was like, because I was taking an approach like, as long as it's unique, then it's fine. Because if I just keep increasing the prefix for these two letters, right? Two words here, right? And then when we reach the fourth one, D and C here, those two abbreviated version of the word abbreviation will be unique, right? And then the same thing for this A5G. So the A5G will also be different than those two. But then we got the wrong answer. So what this problem is asking us is to if we have this three words that mapping to the same abbreviation, we have to keep increasing those letters at the same those prefix at the same time until those abbreviations are unique. So basically what this means is that once we have these three abbreviations, we have to increase the prefix for all of them, like AB 5G, right? AB 5G, and AB 5G. Okay, still there are still some duplication here, right? So we try to ABC, ABC, ABC. Still, right? And then I'll do a DC here. Okay, so once we have A, B, C, D, A, B, C, D here, right? So uh, then A, B, C, D is unique. It's not so, but A, B, C and A, B, C, C are still the same, right? And then we also we just need to keep increasing those tools as well. So this tool is going to become like A, B, C, E, and A, B, C, K, right? So at this moment, these two are also different, right? Then that's when we stop. Okay, so once we have A, B, C, D, right? So after D, we have a 2G here. So this one will eventually become A, B, C, D, and 2G, right? And how about this one? Since we're reaching until this E here, right? This one will become A, B, C, C, E. And the last two is F, G. Since abbreviated the two characters won't give us a shorter word, so we just keep the same. Same thing for this. A, B, C, C, K, K, G. So basically this is gonna be the final answer, right? Not the A5G. I think that's why this this problem got so many downvotes here. Even for me, I didn't understand the concept for this, right? So, okay, you guys maybe have already figured out. So this is like kind of like a greedy algorithm, right? Basically, we are assuming we only try to increase this prefix one by one to check, okay, with this increased prefix, can I make all the abbreviations unique, right? If I can't, I just increase one more prefix. Okay. All right. So let's try to code these things up. All right. So with that, we need helper functions to get abbreviation. Okay. I'm gonna call it abbreviated here. So I'm gonna have a s. I'm gonna have an index, right? Because the reason we need an index is basically that's our starting index, right? So let's say, for example, if we start from the T here, that means that I need to abbreviate it anything starting from the after T here. Because why we need the index here? Because sorry, I'm repeating myself. Because later on we might need to increase the prefix. Basically, this s this is index here, right? This index is telling us what's the current prefix we want to keep for the current word, right? And then, right, then, okay, assuming we have this helper functions, so every time we pass in the original letters, the original word, and the prefix index that we want to keep, right? And then it will give us like a abbreviated version of this s, right? Let's assuming we have that, okay? And then, uh, okay, and then we're gonna have an answer list here, right? And okay, I'm gonna define a few uh, variables here, so something like a dictionary, right? And then basically at the beginning, I'm gonna basically fill everything, fill the initial state of all the abbreviations, right, to here. Basically, I'm gonna do a, no, I think this can be a gonna default 0, right? So here for I in for word, okay, for word in dictionary, right? So we answer dot append, okay, and then it's going to be abbreviations of the word, right? So now we have the initial state of the answers here, right? The initial abbreviations of the answers, and from this point on, all we need to do is we have to basically doing a loop or a while loop or for loop to basically to make sure there's no duplicate element, right? Basically, there's no duplicated string inside this answer here. So how we gonna do it, right? I mean, there are a few ways, and one of them is we do a for loop. Basically, we pick each of the letters. Sorry, we pick each of the word, and then we from here, let's say if we pick the first one, then we're gonna compare. Okay, from here onward, right? Is there any string that is the same, any duplicate string here, right? Uh, if it's the same, then I will add those I will add the index, right? I will add those duplicated the index for those duplicate string into a temporary list, and then I will try to increase the prefix for all the words in that temporary list, and I do that until there's no duplicated words for this for the first for my current base word here. Okay, so and then and then after this one, after this the first for loop, right? I know this letter, sorry, this 12 L2E is unique in this word inside my answer list. Then I move to the second one. I compare from the second one onwards, is there any duplicated words with my second word? And so on and so forth until I reach the end of this list. And okay, so for I word in enumerate answer, right? So mm, let me think. I think I can do this. So the current list, okay. So the current list is uh, I'm gonna put the i's in here, okay. So that's my current list. So I do a while loop, right? I do a while loop, while current, the length of current list, okay, is greater than one, okay. Um, no, I can't because I have to do a for loop here. I have to do a for loop until it's empty. So I think basically I have to do a while true here, and then I will break inside, and then inside I'll create a current list, right, as a set. And so this current list basically will store in the index. We're storing the current index of the duplicated words, duplicated string here. So since we already have the I here, right? So and we start from J for J in range I plus 1 dot n, right? If dict J is equal to okay, I will equals to word, right? Which means okay, we have a duplicated dupe, right? So then we just add that. We add the index. We add index into this here, right? Because we're gonna use the index to append J, all right? And so once the for loop is done here, right? We have all the duplicated indices, right? For the current I, and we can do a check to stop to break here. Basically, if not duplicated, okay, I think duplicate list. This is a better name here. If duplicate list is empty, we simply break, right? Otherwise we'll also add the I into the list because later on we'll be increase the prefix for all the duplicated words, including I here, right? That's why we're gonna do append, no, add. Okay. Yeah, so here this can either could be a yeah, I think we can use the list because the index is always unique, right? So now I just need to increase, right? We have to increase the prefix, right? So by and k in dupe list, right? So what do? We do abbreviation, right? Abbreviate. Okay. Okay. See. So here we need another list to store all the to store the current abbreviations. Sorry, the current prefix for the for this case word, right? Because next time when we do another increase, we have to know what was the previously prefix length, right? And then we're gonna increase it by 1. So with that being said, we need to have a prefix array here, right? 0, and the length will be n. Basically, for each of the word, we're gonna have like a prefix index with n here. So every time when we try to increase the prefix, right, we do what? We do a prefix. Basically, here is going to be the indices, right? Since we're using the indices here, we can simply use the k here, and we do a +1, right? And then we're gonna put this answer the back to, since it's also the indices, equals to what? Equals to the abbreviations, the as the same, right? And then the prefix k, right? So here in the end, we simply return the answer, right? So basically here we are using another like list, n-dimensional list to store the current prefix positions, right? For this current word. And every time when we decide, okay, we need to increase the prefix for this current answer here, basically we'll be passing the s and the indices here. That's why inside here we're gonna use the indices do some checkings here, right? So basically n length of the s, right? And then the indices, right? So if the n minus the index is equal smaller than 3, then we simply return s. Yeah, right. Because why is that? Because let's say we have a B C D E and F. Okay, so the n is 6, right? The indices could be from 0 to 5, right? And when is the place we will be returning the original word instead of abbreviation? It's when there is like when there is when the indices is right here, right? So when the indices is here, then which means there are only two words, sorry, the two letters left here. Then we don't need to do any abbreviation. We simply return the original word, right? And here is what's the indices for here? That's the 6 minus 0, 1, 2, 3, right? So here's a 3, which is 6 minus 3. That's why we use this n minus indices is less than or equal than 3, and then we return the s. Else, right? Else we need to do a regular abbreviation, right? So that's gonna be the s to the indices plus 1. That's the prefix, right? Plus a string of the n minus indices minus 2, right? Plus s minus 1. So the s minus 1 is easy to understand. That's the last one, right? How about this here, the minus 2 here? And again, I know it's hard to for those kind of like range here, but let's see. So if the index is b here, let's say if this is the indices, the I here, right? So which means we'll have we'll have a and b as indices, right? So it's gonna be the a b and the prefix, and it's gonna be 3 and f, right? So the 3 is the one we're trying to calculate it here, right? So how do we get the 3 here? Basically, we have to remove n minus indices minus ones for the prefix, and then right and then we also need to minus 1 for the last character, right? And the rest will be the length that will be abbreviated, will be compressed. That's why we have this n minus index minus 2, and then we convert it to a string, right? Okay, so yeah, basically that's our helper function, and then once again here we do a for loop. Okay, so you know what? Let's try to run it. Hmm. Okay, while true. Hmm. Oh, here. What am I doing here? Why am I using as here? Um, dictionary.k, right? That's the original word. That's the original word we're using because we're storing the indices here, right? Yeah. Hmm. Let me see. Hmm. Maybe it's because here of the word here. Maybe I shouldn't use the word here because we're constantly updating the answers, the answer array here. So I believe it's not safe to use the word here. So we should just use like the indices, range n, and here I'll just use the indices of the current I, sorry, of the answer I. Oh, I see. I think I see what's going on here. So it should be answer I and j. Maybe it's okay to use the enumerate here, but since I already changed it, basically we're checking the answers, right? Not the original dictionary. We're checking if there's any duplicated abbreviations, not the original word. Okay, so let me try to run it again. Okay, cool. So this time it's passed. All right. Okay, so it passed. This problem it's kind of trivial. It's you can say it's a greedy problem, but more than that, it's all about how you can do this for loop. Basically, how you can make sure how you can eliminate all the duplicated strings in the array, right? By basically we increase the prefix one by one until there's no duplications for the current I, right? And then we keep going until we reach the end of the word of the list. Um, yeah, I don't know what else I want to talk about this, but I think that's pretty much it is. Yeah. So cool guys, thank you so much for watching the video and have a good night. See you.